Hi everybody, Mrs. Kroll here. This video is going to go through all the IVT questions, so 11, 12, and 13. First one, number 11, let f of x equal that piecewise function there. Although f of -1 equals 0 and f of 1 equals 1, f of x does not equal 1/2 for all x's in its domain. Why doesn't this contradict the IVT? So first things first, let's graph f of x, this piecewise function. And it says for all x's that are less than or equal to 0, we're going to be at 0. And then for x that is greater than or greater than 0, we're going to be at 1. So open circle and then straight line to 1 through 1. Now f of -1 equals 0, so I'm going to put an ordered pair at this spot. That's saying at -1, we're equal to 0. And at +1, we're at 1. And IVT says if -1 is equal to 0 and 1 is equal to 1 on a continuous function, there would have to be a 1/2 somewhere in that range. Somewhere we were going to hit a y value of 1/2. So why doesn't this contradict the IVT? Well, this doesn't contradict the this doesn't contradict the intermediate value theorem because the function is not continuous. So let's write something here. This does not contradict the IVT because f of x is not continuous. And since the function is not continuous, we really don't know what any of the y values are, or we can't guarantee any of the y values, so we don't ever know that it's going to equal 1/2. We know that the function is not continuous. Because the limit as we approach 0 from the left of the function does not equal the limit as we approach 0 from the right. All right, moving on to the next one. Now, in this one, we're looking, is there a value c on the given interval, 0 to 3, such that f of c is equal to 0? If yes, determine that value. So we're looking, is there going to be a y value of 0? That's my goal that I'm looking for. So the first thing we got to do is f of x going to be continuous? And in this case, it is. Because there's no fraction, not a piecewise function. So the first thing I'm going to do is I'm going to plug in 0. When I do that, I'm going to get 0 minus 0 plus 8. And then I'm going to plug in 3. And I'm going to get 9 minus 18 plus 8 to give me an answer of -1. All right, so we know that we're going to have a y value. Because the y values go from 8 all the way down to -1, we have to hit that value of 0. So I'm going to start by saying that. So yes, the IVT guarantees that f of c equals 0 from 0 to 3 because f of x is continuous on that interval and -1 is less than or equal to 0, which is less than or equal to 8. All right, but then the next thing it wants us to do is it wants us to find that C value. So we're going to be looking and setting, we're looking when is it equal to 0? When's that Y value going to be 0? So set the 0 equal to the function. And this is nice because it's factorable. X minus 4, x minus 2. And so the two places that it happens to be equal to 0 would be at 4 and at 2. However, we're only looking in the range from 0 to 3, so this is out of that interval. And so 2 would be our only possible answer. So the last part we're going to put in this sentence is we're going to say f of c is equal to 0 when c is 2. All right, same idea for 13. Again, we're looking, is there a value c on the given interval such that f of c is equal to 6? If yes, determine that value. So again, we're going to be looking, is this going to be a continuous function? Well, the function in general, overall, is not continuous because we know that we're going to have a vertical asymptote at 1. I'm just going to write that over here. So vertical asymptote at x is equal to 1. That would make my denominator 0. But 1 isn't on the interval given. We're looking from 5/2 up to 4. So in this one, we know it's continuous on that interval from 5/2 to 4. So the first thing I'm going to do is I'm going to plug in 5/2 into the function. So 5/2 squared would be 25/4 plus 5/2, which I'm just going to make 10/4 right away because that way then I have common denominators. And I'm going to divide that by 5/2 minus 1, which I'm going to make, again, common denominators right away, 2 over 2. So that this is going to become 35 over 4 times by the reciprocal. This would be 3/2 down in the bottom, so that's going to be 2/3 multiplying here, which this cancels out to make this 2 in the denominator, so it's going to be 35 over 6. And then I'm going to plug in 4. And when I plug in 4, we are going to end up with 16 plus 4 over 4 minus 1. So we'll have 20/3. All right, and so then if we're looking at this, we're trying to see if 6 falls in that range. So if we would think about 35 divided by 6, that's about 5.83, the decimal. And then 20 divided by 3, then we're looking at 6.67. And so 6 does fall within that range. Now it looks like I'm going to kind of run out of room here. So I'm just going to write small here. Yes, the IVT guarantees that f of c is equal to 6 from 5/2 to 4 because f of x is continuous from 5/2 to 4. And 35/6 is less than or equal to 6, which is less than or equal to 20/3. Okay. So then the next part that we need to figure out is when is it equal to 6? So I'm going to set 6 equal to my function, so x squared plus x over x minus 1. And well, I need to get rid of the fraction, so I'm going to multiply both sides by x minus 1. Or really the whole thing. So this is going to be 6 times x minus 1. So I'm just going to distribute the 6 in right away. Equals x squared plus x. And then we need to start to solve this for x. So I'm going to start and factor it. So x squared minus 5x plus 6. Which is going to factor to... I'm out of room here. I'm just going to go ahead and I'm going to erase some of this from the other problem. Draw an arrow up here. All right. So I have 0 equals x squared minus 5x plus 6. This is going to factor to x minus 2, x minus 3, to give me an answer of 2 and 3. And again, just like it was on the last problem, not all of them fit in the range. X equals 2 is too small, so 2 gets crossed off here. And so 3 is my only answer. So coming back down here into like my sentence, I'm going to say that f of c is equal to 6 when c equals 3.